Hi, my name is Michael Morehead, and I'm a co-founder and the CEO of syGlass, a company that develops virtual reality software for the visualization, analysis, and communication of 3D image volumes, like CT scans, MRI, and 3D microscopy. In 2013, I joined Dr. George Spiro, a neuroscience professor, and Dr. Gianfranco Doretto, a computer vision expert, in a research project designed to create a new 3D visualization system for large-scale neuroscience connectomic data. We learned many things doing this research project, and around 2015, when virtual reality headsets became commercially viable, we decided to transfer our knowledge into VR. Over the 5 years, we have developed many new features for the research scientist, medical practitioner, and science communicator. Why don't I put on the VR headset now and show you around?
Hi, welcome to syGlass, where we can hold our data and explore it volumetrically. We can reach out with our two hands and rotate it around in any direction. We can bring out our cutting plane and slice through the data, looking on the inside and giving us an extra view and understanding of the spatial and morphological features of the data set. Let's check out some other things now. When we first started, we were primarily focused on neuroscience research data, like this. As time went on, we found that volumetric data was everywhere.
We've been approached by geologists, surgeons, plant scientists, virologists, and industrial manufacturers. Volumetric imaging is the next step to understanding our world. One of the first challenges we faced with syGlass is that research scientists now routinely collect data sets that are 10 to 1,000 times larger than a conventional CT scan. These data sets range from 20 gigabytes to several terabytes. We have overcome this by creating the syGlass rendering engine, built completely in-house specifically to visualize these very large data volumes. Our current record is a 20 terabyte volume generated by the Mouse Light group at Janelia Howard Hughes Medical Institute. Our customers routinely explore 300 gigabyte light sheet datasets, like this one shown now, featuring cleared mouse brain with fluorescent labeling. As we have overcome these big data challenges, and medical imaging continues to improve in size and resolution, we are well positioned to handle any amount of data in the future. We were extremely proud of the beautiful visualization and immersive exploration in syGlass, but our scientist customers needed more. Without the ability to extract numerical statistics from the data, syGlass would only be half of the solution. In 2020, syGlass won a direct-to-phase 2 SBIR Small Business Innovation Research Grant from the US NIH to develop and apply state-of-the-art machine learning techniques to the software. The combination of virtual reality and machine learning allows users to quickly add ground truth or correct machine learning errors. In the future, we believe syGlass will become the central piece to a human-in-the-loop workflow, where artificial intelligence is continuously updated by the actions and requests from the user. In this video, we show an automated cell counting workflow that has just been released to our customers. With automated counting, we have found that we reduce the time required by 98% of manual counting. We can also present statistics in our 3D scatterplot system. Here we show an example of the California housing prices with on-the-fly variable swapping on each dimension. We have begun working with medical practitioners to find the best use cases for our new technology. One excellent use case for virtual reality is pre-surgical planning of specific surgical workflows. For example, in severe epilepsy cases, surface EEG is used to locate the source of the epileptic seizures. Then, the source can be surgically removed. However, in some cases, surface EEG cannot always find the source. Instead, invasive depth probes are implanted via surgery, and the patient will wear them for 2 weeks while brain signals are recorded. These depth electrodes must be placed in specific regions to increase the odds that the doctors can triangulate the source of the seizures. The electrodes cannot get near each other, blood vessels, or specific vital areas of the brain. This creates a 3D puzzle that grows in complexity as more probes are needed. Sometimes, a neurosurgeon will need to implant up to 20 probes. Planning this procedure is currently done in 2D. Our collaborator neurosurgeon, Dr. Nick Brandmeier, asked us to build a planning workflow where he could place the electrodes in 3D. With this system, the surgeon can accurately and quickly understand all of the spatial issues with each electrode placement. We are now working on setting up a large study to show the time savings of this workflow. Another advantage to this system is post-operative communication. Neurosurgeons must work with neurologists to help assess the electrode data to triangulate the epilepsy. We have built into syGlass a volume registration system so that MRIs and CT scans can be superimposed and read together. This system helps the surgeons communicate to the neurologists exactly where the electrodes were located after the surgery. While the world was locked down, we needed to find new ways to meet with our colleagues and collaborators. Although video calls work, they often feel unnatural and exhaust the users. Virtual reality provides a way to simulate a real meeting from the comfort and safety of your home. We have developed syGlass Multiplayer, which allows 32 users to meet together around their data. Users may present slides and other data alongside their 3D images, and spatial audio really makes the experience just like meeting in real life. One of the most important capabilities for this technology is the ability to archive key insights. To facilitate this, we've built the syGlass narration system, which records your voice and actions along a timeline. When played back, your avatar appears and repeats all of your actions and words. This is an incredible tool for transferring wisdom and information. Imagine learning heart anatomy from the world's top cardiologists. With this system, doctors, nurses, and patients can record their thoughts, concerns, or questions about the data. These narrations can be replayed at any time, at the practitioner's leisure, for asynchronous communication with the patient or support staff. Information is useless unless it can be shared. We have built the cloud-based syGlass Data Zoo to provide a platform to share datasets and narrations. Now users can upload their data or narrations to the cloud, and anyone in the world can access it. In summary, syGlass has built the base technology to enable holistic visualization of 3D data. While we will continue to serve the scientists of the world, we can also do more. In medicine, there is still a major deficiency in the user experience. Patients can be scared and confused about their situation, but studies show that when more education and information is provided, the patients have higher satisfaction and compliance. Imagine a new system where the patient could walk through their medical history as a timeline, comparing scans from 10 years ago to today. Imagine having all of your medical records at your fingertips, with the ability to send off questions to your doctor at any time. When the doctor responds, they can pull up the correct scan or lab result and show exactly the issue. From a physician's perspective, why not have a patient-centered VR chart in 4D, rather than a series of scattered relational databases of redundant 2D data for a patient? Envision an anthropomorphic or living chart in virtual reality that you can scan through as if you were looking at the patient. A systems or disease-based comprehensive approach, including big data, integrative, and cross-referenced with history, exam, labs, images, and more. This is the future of electronic medical records, powered by syGlass. Thank you for your attention.